Hello, hello, hello. Good evening, good morning, good afternoon, good night, good day, everyone. So we are back. Let me just, for some reason, I'm not logged in on YouTube here for chat. See, I need to go to my phone. Yep, it's me. Okay, need to move this a little bit to the side. Hey Damascus, how are you, my friend? Yeah, good to see you guys too. I miss you a lot. I miss streaming, I miss all this stuff, but life isn't how we want, it's how it is. So yeah, I've been extremely busy. And finally, I'm basically forcing myself to do some stuff. It's not that I am any less busy, but I really need to get this going. We have people waiting, we have money on the side, and we need to get results, right? So welcome everyone. I hope everyone is fine. So yeah, we are not starting the build yet. I'm printing the parts that we need for the casa, and I still need to check what we need to print for the actual Milo. I haven't printed nothing yet. Well, nothing for the Milo. I've printed a bunch for the casa. Yeah, that's the usual. But yeah, so as I was saying, my printers haven't been very collaborative with this build. I had a lot of troubles with my Trident, with my Scylla, with my Micron. Anyway. Yeah, welcome Charlie. So yeah, my Scylla. So first my Trident, it's been a fantastic machine. It's still working. It's nothing. It's just the extruder parts. It's a stealth burner, and the extruder parts just gave up. I needed to print another set. Actually, just one of the parts broke, so I had to reprint it. It's working now. Scylla. I needed a bigger plate for multiple parts. Scylla, it's fine. It's just one thing that I don't like on the stealth burner mount for the bamboo hot end. So I thought I was having layer shifting, but it was weird because usually layer shift it's on one axis. It's very rare to have exactly the same amount on both axes. So I was having like a layer shift on Y, and being a Core XY, usually the layer shift it's on diagonal, because you'll skip steps on one motor unless you are, well, I don't even know the chances of having the same shifting on both motors, so it will translate into lost motion on Y or X. So I was having problems, and turns out it was actually the hot end that was moving on Y. So First guess, you're right. So maybe the screws got loose, but even so, you know the Bamboo Lab, the bamboo type hot ends, they are fixed by 2 screws on the side, on the top of the hot end, and really it's a shitty way to do it. So what was happening, actually, I think I have parts here. Yeah, so this is the thingy, and actually I can show because I actually have a hot end here as well. Hey Kegel, how are you, my friend? So we are talking about these hot ends. These are very good, just the holding mechanism, it's shitty for our type of stuff. It's good for the bamboo, it's not that good for us. So this thing on the Dragon burner goes in here like that, and it's soldered by 2 screws there, so on the side. So what happens is, on the original design of this part here, the screws are perfectly centered with the holes here, and these holes, by the way, are bigger than, so these are supposed to take M3 screws, and these holes probably are 3.5 mils, which is not ideal for these. It's good for clearance, but so what I did was I just increased the floor there on the bottom. So basically I'm pushing the hot end, so it's like this, the hot end lower, but I left the screws on the same place, and I offsetted the floor by 0.5 millimeter, and now the screws will actually force on the top of the hole. So that means that all the so my problem was this thing was moving like that, was oscillating like that, and I thought it would be a layer shift, but it was just the hot end shifting positions. So what I did, this is actually a new design, a new model. I need to change all the heads on the Skyla. So what I did was I pushed the hot end down, and now the screws will actually will be entering with an interface on this thing, pushing the hot end up while it screws in there. So instead of just clamping it, it's actually forcing the hot end up, and this way it will force the hot end against this part, and now it will never move again. So I don't know if anyone else had this issue, but I had, and that's how I solved it. Now I need to change all the other 5 heads on that thingy. I'm doing good, Kegel. What about you? Extremely busy. So my Micron has 2 issues. First one, it's also the extruder. The extruder, I think, so this has the Micron extruder. I don't know how it's called nowadays. Hey Jose, how are you, my friend? Basically, it's the specific for the unted or whatever. I don't know how they call it nowadays. Extruder, I think the tolerances are too tight and I'm skipping the filament. So no matter how much I tight the spring, the filament still skips. So I'm guessing something moved with probably the heat. And so I need to change that thingy to a regular wristwatch. I have the parts printed, they are on the table. I just haven't messed with it yet. Also, I have another issue. So the front idlers are showing the belt. So I need to rework the front idles to increase the spacing. I think it's too tight. I need to take a close look at it to figure out. Maybe I'm gonna rearrange the shim spacings whatsoever. I need to disassemble it and redo the belts on it. So I'm gonna do everything together. Probably I'll do a stream about it. We'll see. The V02, it's absolute beast, never misses. And the Tridex, it's working. It needs some calibration. Since I changed the adjustable second head, I haven't printed a thing, but I'm gonna need to print some stuff for Milo on the Tridex, so I'm gonna get to it soon. But yeah, lots of work, not as much as free time as I would like. Hey Marco! The Skylar is printing right now. Yeah, I left some stuff. Actually, the Skylar needs something else. Oh, actually, I need to drop my mic a little bit. So the Skylar, I have a problem with the spool holders. It's not a problem. The problem, it's an... How can I say it? I don't know how to say it. So the problem is when I think the problem is the actual spools. They are too light. These card spools are too light. And when the filament, when we are printing with hard stuff as ABS or whatever, when they get too close to empty, they become too light. And today at the end of the print, the spool was almost empty. The damn spool fell, so I need to print some round stuff, some round boxes, like so basically what I want to do is, I'm talking about these spools, I need to print something that fits in here and fill it with like lead or sand or something heavy to make more weight. Because today the spool fell and I fucked up the prints that it was doing because of it. So I need to figure that out. So I need to print some kind of cases, something like these, but something like this that I can fill. So these are for silica for the moist, so but these won't fit on the hole. Oh, actually they kind of do. Okay, so I have two of them, so I can use something like this. Yeah, it needs to be a little, and ideally small enough that fits in here, so it will just roll inside the spool. That's the idea. Anyway, so let's go to the business today. So today we're gonna go very soon. I'm gonna do the resin printer unbox, because yes, I bought a resin printer, and yes, it's back, it's down there in my home for probably 3 weeks, more than 3 weeks, almost a month. Well, probably more than a month actually. In the boxes, exactly how they arrived, and I don't even know if the printer works. So soon the warranty will void, and I haven't even tested the machine. So yeah, I did some kind of cleanup in the back. Well, I did a cleanup. I haven't organized anything yet. So we have a bunch of filament up there. We have a bunch of storage boxes there. And I'm rearranging all the stuff. We have the dryers there, and yeah, a bunch of garbage there in the floor. So yeah, the resin printers will go here. I bought a resin and a washing station, so they will go here on the back. But yeah, so very soon this week, probably next stream, maybe Wednesday, Thursday, I don't know, I'm gonna do the resin unboxing because I really need to print some stuff with it, and I need to know if the machine works. That's the main thing. But yeah, so what else? Okay, let me see. I don't even know if the... Ooh, nice. Sunlu SP2. What about the Skyla, Marco? The Skyla is printing. Yes, the Skyla has a lift bar. Let's see if we can... So if I go... I don't even know how to work. Okay, probably here, yes. If we go... It's not here. I don't think... Is it this one? Yes, probably is. So yeah, it's printing okay. We can see the lift bar. What about web? No, not really. So the lift bar is somewhere in there. So we can see it. Yeah, the autofocus is acting up. Well, at least it's working. The camera is working. It wasn't one of these days. Why are the bed fans not working? So the bed is at 80. Yes, the Skyla has a lift bar and everything is controlled by Clipper. Oh, probably because... No. Let me check something. Why the bed fans are not working? Oh, because I have a... Oh, fuck me. Let me put 75. Save, okay. Let's activate the bed fans. 60%. Oh, can go 80%. Okay, so let's go to the, well, first, let me see how is the top camera. Probably I have a big screen. Yeah, okay, I have the screen at the front. Oh, we can move it back a little bit. So today what I want to do is actually design the, okay, we don't need these for the control panel. So the idea today is to design the control panel, and I want something like, so we have the screen, so it's a 16-inch touch screen, like a portable one. So the idea is to have I want the thing the smallest that we can make, but that everything will fit. So this will be the main screen for the machine. And probably we're going to remove this thing as a stand. Well, probably the stand can go all the way like that, or maybe, oh okay, it has screws, so we can disassemble it, I think, because we don't need it. Okay, so the idea is to have the screen. I bought this keyboard for this. Let me so the screen, I bought it from AliExpress, of course. It's not expensive. I'm gonna make the panel myself. I know, I'm gonna make the panel myself. So this is a Milo, this is not a DMG Mori. So I bought this keyboard. An industrial screen will cost more than the machine itself, so no. So I bought this keyboard. It has touchpad, and the touchpad actually can act as a numpad. So I'm not sure. Well, I probably can show it on camera if I remove the... So, see? It can work as a touchpad, numpad, which is cool. So we can insert the numbers on the keyboard if we don't want to use the touchscreen. So the idea is to have something like that, kind of straight, so in parallel with the camera, but then the keyboard something like that at an angle. Then what I bought more? So I bought a shit ton of buttons. Small buttons, big buttons, light buttons, emergency stop button. Hey Questionable, I saw your message. I forgot to reply, but I have kind of good news for you. But I'll send you a message in private. So this is a emergency stop. I thought it would be bigger from the picture, but yeah, that's what I got, and it's probably it's fine. Okay, so I bought so single press buttons, latching buttons, multiple color buttons. So these are latching. So these are the this is the connector for this one. This is double color. So we can use it like red when it's not green when it's not active, and when we push it, it can change to red. Fancy. So we have these bigger ones. I want to use these for axis movement. So the idea is to use these as axis movement, so probably I'll laser engrave the X plus, X minus, Y plus, Y minus, Z plus, Z minus, and B and C, A and B plus, and A and B minus. So yeah, I have a bunch of them. So the idea is to use these and we'll see what we need. So we're gonna need for the, yes, it's gonna have the trunnion, 5-axis trunnion. Actually, I got it, but I have it downstairs if you guys want to see it. I'm not sure if we're gonna be able to use it on this machine at first, but we'll see. I think we need to grow the Z. But for now, that's 5-axis. It's for in the future. I just want to prepare everything for the 5-axis. So yeah, that's the idea. So the idea is to have the keyboard. Okay, so these are latching, probably for the rapids. Yeah, I think I ordered for the rapid. So if we engage it, it's gonna jog the machine at the rapid speed. Also, there's another stuff that I need. Where is it? So it's here. I also want to install 3 3 LED 7-segment LED displays. So the idea is to have a direct visual to to whatever value we are in here. So the idea is to have one for the rapids, one for the feed, and one for the spindle, and these will be controlled by potentiometers. So I have some potentiometers here as well. So the idea is, as we move the pot up and down, we're gonna have a direct read on this display, and it will send the information for Linux CNC corresponding to the thing. So the idea, so this will be fully, no, I'm not gonna, the pendant, I also want to install a pendant, but the pendant, I actually have one already, so you should be kind of plug and play. I have a wireless one that I don't use on my Mac 3 machine. So this will be on the console, so it will be on the panel. So yeah, this everything here, so from the buttons and this part of the controller, so the potentiometers, the displays, and the buttons will be controlled via Arduino. So I have an Arduino Mega somewhere in here. So we're going to use this guy to interface this stuff with Linux CNC. Hopefully, that's the idea. I kind of did some testing, but just on Arduino, not on the CNC, on the Linux CNC, just to figure out if I could really make the stuff behave like I wanted. So the idea is to move like in multiples of 10 or 5. We can, this is the good stuff. It's going to be fully programmable on on the Arduino, so we can control it by 1 by 1% or 5 by 5 or 10 by 10. The idea is should be like something like from 0 to 300% in 10 increments. So 0, 10%, 20%, 30, 40, 50, up to 300%. So, or 200. We can easily change. That's the beauty of it. We can easily change the programming of this user interface. So yeah, that's the idea. So yeah, we're gonna have the idea is to have 3 potentiometers, 3 displays, each potentiometer under a display. So it will control. There's a nice knob here. So one's going to be again for rapids, feed and spindle speed, so we can adjust it on the fly. That's the idea. I'm not saying that I can do that, but that's what I hope I can do, and I'm gonna prepare everything as if I can do it. Probably before we're gonna start build the panel itself, I'm probably gonna try it. But yeah, that's the idea. So the idea it's with that. It would be nice to add some more stuff. We probably leave some space. I would like to have some kind of, but we can use some just lights for that. Some like LEDs, like an RGB LED for the coolant level would be cool. It's not that easy to implement, and it's going to be fully on the Arduino. No need to mess with the Linux CNC there. So basically something like, I don't know, maybe RGB LED changing from green to red according to the level of the coolant tank. I'm not going to use flood coolant. I'm going to just use a mist. Would be cool. So I want buttons to manually kill the coolant or activate the coolant. So like, I want one that I can just disable or enable the coolant. I mean, and if the programming, basically it's just a switch on the in series with the valve that will actuate the coolant. So if you program coolant, the machine will run coolant if that button is on, and if you turn it off, it will disable the coolant. So basically, if you don't program the machine to run the program with coolant and you turn on the coolant, it won't, that button, that same switch, it won't activate the coolant. So it will just kill the coolant if you need, if you want. Let's say you forget, you forgot. Probably this can do it with Linux CNC, I'm not sure, but I want to have that option. So manually kill the coolant. The spindle motor coolant pump control. So you have M codes for the for specific for the coolant. So if you run M8, I think it's M8. It's the flood coolant. It depends on the controller. I need to check how the Linux CNC is. It depends on the controller. So, but basically, I'm not going to run flood. I'm not going to run any pump for coolant. It's going to be pressurized. So it's going to be mist. So it's just a flow of air with a drop of coolant every few seconds, and we will create a mist. So a water-cooled spindle. You just run the. Soon as you turn the machine, you put the cooling of the spindle running. It's if the machine is on, the spindle coolant is running. Unless you want to use something like a chiller, or you can use a thermostat, where you can just put a probe on the spindle, and soon as when the spindle reaches that temperature, it automatically starts the water running. But that's nothing to do with Linux CNC. Of course, you can use it like that, or like when you start the program, you can activate a relay or something like that will start the coolant, the pump for the spindle cooler. That's up to you. For me, if I was doing a water-cooled spindle, soon as I turned on the machine, the pump would turn on. That's plain and simple. Okay, so yeah, this is the idea. I want to have a button for. So I want to have buttons to control all axes. So that's like 10 buttons. I want one to be able to select rapid, so to jog rapid, let's call it that way. So it's going to be a latch one. When you press it, it's going to activate the rapid, and so when you jog it, it will jog the machine at maximum speed. I want to have the 3, so that's 11 buttons. Then I want the one for the coolant to activate or deactivate the coolant. So as I was saying, I want one basically to cut off the coolant if we want. Basically it's to cut off, it's not to activate it, it's just to cut off if we want it. And I want one to do the opposite, to activate the coolant if we forgot to. Let's say we did a program and we forgot to activate the coolant, so we can go there and manually press that button and activates the coolant. Probably the first one, it's going to be probably not probably, it's going to be in serial with the solenoid valve that will activate the mist. The second one probably will be interfaced with Linux CNC and just call it for M something to activate the cooling. What else? So one for the rapids, one for the lighting of the machine. I'm not sure if I'm going to use, so if we watch here on the, let me put this aside. So if we watch here, so here we have 2 buttons. So we have the Holy Shit button and we have 2 rock switches. So this is for turning on the machine. I'm not sure why we have 2 in here, but one for sure is to turn on the machine. Yeah, that's granted. The other one, I'm not sure if I'm gonna kill one for the motors power supply and one for the other power supply, so for the system, or if I'm going to use one for the lighting. But I don't like to use, I think I will use for, I'm not even sure if I'm going to use both of them, because I don't want to by mistake turn off the machine. In fact, probably I'm going to print a guard for the main switch, and I'm going to change this part to have like a guard not for us to kill the machine by mistake. This one needs to be like that because it's for emergency. It's kinda, but yeah. We'll see. About these two switches, I'm not sure. I'm not sure what I'm going to do with them. So one is for turn on the machine, that's for sure. The second one, I'm not sure. I may do one for turning on the system power supply, so it should be like a 24-volt power supply. And the second for the big power supply, I'm not sure. I need to think this through. So yeah, we'll see. Okay, so anyway, we'll go ahead and start doing stuff. Let me put this aside. So I'm not sure if probably the mini computer, it's gonna stay on the main cabin, so probably the mini computer will stay here on the main cabin. I haven't even tried. I need to check these to see if I can make it work with Linux. I hope so, because this is an Intel. What's this? Okay. So yeah, so this thingy. Need to check that, but yeah, probably, I think so, I hope so. Otherwise, it's a paperweight that I need to sell. Yeah, it should work just fine. It's Intel based, so it should be fine. So this is the, I'm sorry, I'm on the, so this is the CNC controller, so the Mesa board. Again, first we're gonna start with the parallel port setup, just to test the machine and prove that it works, and you can go cheap. But yeah, this is going to be the final. Yeah, that should be fine with even with 64-bit. It's a new PC, so it's going to be fine. It should be fine. I'm pretty sure it's going to be fine. We're gonna test that soon. I need to start, because I never used Linux CNC before, and I really need to get into this Arduino communicating with Linux stuff. It's gonna be Let me check how many USB ports this thing has first. I may need a USB hub for this thing. So we have 3 USB. No, oh, we have 4 USBs. That's a lot. 2 USB 3s and 2 USB 2s. We should be fine. We only need what? One for keyboard, one for Arduino, and yeah, that's it. Then we have HDMI for the thingy. I need to figure out the power on. That's gonna be fun. I need to check if this thing has a BIOS. I know this thing can easily... Oh, okay, it's here. Yeah, disconnect, sync. Because this thing can use a SATA drive. We'll see. Oh yes, we need another USB for the... Yes, we need another USB for the touchscreen. I was forgetting about that. Yes, that's true. We have a Ethernet for the Mesa card, so we're gonna be fine. So the Arduino needs to be on the panel. So we're gonna need power for it, but we're gonna need power for the LEDs as well, and the whatever. I'm pretty sure this guy needs, yeah, it needs USB for touchscreen. I'm pretty sure it does need USB for the touchscreen. Probably, I'm pretty sure, or with HDMI, of course. If like connecting it to a phone via the USB-C, probably it doesn't need it. But with HDMI, I'm pretty sure it needs a USB cable. Okay, so yeah, let's get to business. Yeah. So first thing, I'm going to create a new folder here for the control panel. Just so this thing is messy enough already, so the idea is to attach the control panel somewhere here on the side in a way that it kind of hinges. So the idea is I want to be able to fully fold it to probably to the front of the machine, like if I'm not using the machine. So fold it to the front, and basically it's gonna sit in here. And when I want to use it, I just unfold it to, but that's for later. And unfold it to the side. Usually it will work like at an angle like this. And No, what no? I don't think I have space to put it on the top, so it would be nice actually to put it like, maybe I have. That would be cool. Because the machine it's not going to be tall at all. Ah, water coolant and the table moving smash the screen. No, I mean outside, man. I mean outside. I mean like on the outside of the machine. Of course not the inside of the machine. Why would I put the control inside the machine? I want to fold it so it will be on this side like that. When it's folded, oh, actually on the front. On here. And when I open, it's going to be here. Okay. So let's start first. Let's make dummies for the stuff that I need. So I need the screen. So I'm gonna create a dummy for a dummy model of the screen. So we need a rectangle of, and I need a tape measurement. Why is my clothes, my rags, not my clothes, on the floor? Yes, but the door, well, that's a good point. Because the door, it's like, okay, I need to check that. The door, yeah, the door moves out, right? When it opens. Okay, yeah, need to take that in consideration, but so 35.5, so 355, and that's a good point. 237. Extrude. How thick is this? Not too thick. Let's say 18 millimeters. Oh, actually, yeah, it's fine. 18 millimeters. Let's make it full. 18 millimeters. Now the screen itself, it's 345. Yeah, 345. by 218? Yeah, 218. A little less, but 218. Okay, so create point. Where is the center point in here? And in here. And kaboom. And from here to here we have probably a 5 mil edge. Yeah, 4 mil, 4.5. Let's call it 5 mil. Good. Let's just do a recess of -1, just for us to have a clue where the screen actually is. And let's save it. Yeah, I'm gonna make everything on the same file, so okay, now we're gonna create a component from this body, and we're gonna call it screen. Boom. And we're gonna hide it for now. Now, let's create a keyboard. So the keyboard will be, I want to be able to just remove it. This thing runs on batteries, I believe. Pretty sure. It's not rechargeable. Yeah, this thing doesn't want to open, but from the format, pretty sure it's 2 AAA batteries. So I want to be able I just want a place to sit it there. So basically a box to sit it there and being able to remove it to replace the batteries when needed. And if it dies, I just want to be able to put another one in that place. So yeah, let's just make a simple model of it. We're gonna make it a little different. This guy. So the screen is okay, perfect. Edit sketch. Good. Okay. Let's make a ball. I need fifteen mils, and the front is something like 5 mils. Yeah, 5 mils. About 54, 5. Let me create a point here, a point here. Let me set these to vertical, and let me set these to horizontal. And these will go like there, and these will go like that. It's kind of like this. It's different, but for the purpose, that's good enough. So it has 100. So I need to create a point. Well, yeah, okay. Like that. Let's make these like that. And these to here. 100. Boom. And now extrude this guy, this guy. 260. 260, boom. Like that, we have a keyboard. We can round the corners just to make it a little more. This looks like a 4 radius. Yeah, that's good. I'm not gonna mess with it more. So we are gonna create a component. We're gonna rename it for a keyboard. Good. Now we have two sizes of switches. So we have 24.7 ones. Yeah, I can use the same. I can use this plane. Doesn't really matter. This button configuration, it's different from my main computer. So we have 24.7. And let's make it 2 millimeters high. Now let's do a chamfer. Yeah, two distance look good. 1.5 and the second one, let's put something like 1.6. The second one, like, I don't know, 2.5. Oh, so it's the other way around, 2.5 and 1.6. Yeah, that's it, kinda. Okay, more like 3. Yep, like that. Here we have 21.8, so it's 22 millimeters. I'm gonna make it 22. And something like 21. Yep. Let's just make a little ring in here. $18. So where's the center? Come on. 18. I'm just gonna edge it 0.3 millimeters just to make it noticeable. So this is the, let's do a chamfer here. Normal chamfer. Oh, actually, let's leave it 2.2. Yeah, just to look better. Let's create a component and let's call it SW22. So it's a switch 22 millimeters and we have a smaller one, a smaller type. Shit. Same. So these ones are 17.8, and $1.8. Same story. Probably 2.5 and 1.5, something like that. Again, this is just a dummy. No need to be very precise. So the button itself, it's like 12 millimeters. E minus 0.3, again, just to make this guy is 16. And this guy is 21 as well. Same story, we're gonna make a 2x2 chamfer in here. Good. And we're gonna call this guy. We're gonna call this guy switch 16. W16. Good. Now we're gonna need the mushroom button. I probably don't want to use the cable connect the wires, because I think it's, yeah, I don't know, we'll see. They are too small anyway. Probably I'm gonna run directly to the button. We'll see. So for now, looks good, feels super nice, just a little small. And this thing was kind of expensive. I think it cost me like $7 or something like that. I check. Oh, I'm not signing in here? Shit. Yeah. Okay, so how am I? Okay, there's another way. Let me... I'm gonna put it here and... Okay, let's switch. Not sure. Yeah, okay, it is. Okay, so these are the switches, the other ones. So, fuck, probably. Why is this thing in Portuguese? I hate. Okay. Yeah, it cost me $17 both thingies, so yeah, it was not cheap at all. I think I ordered... What did I order? Order details. Okay, yeah, 924 volts, so it means I need to run it on a relay or SSD, SSR, sorry. Okay. Moving on. Okay, so we're gonna need a model of this, nothing too fancy, but we need a base model. So I'm gonna start with a thread. $22 mils and 30 mils. Okay. So 22 extrude 30, then it grows to 27 for 16 mils, like that. We're gonna do a fillet, like, yeah, that looks good, like that. That's fine, good enough. Let's do a 2x2 here, and let's do just some painted red, just to be different. And create component, and let's call it HS button. Holy shit button. So we have some pots that we're gonna need as well. What's the biggest thingy? So the knob, it's easy to do. Same plane. Go away screen. This thingy. Okay, so this thing is 25 millimeters. 25 and 13. Now we have a centerpiece of 9. Probably about 10 millimeters. Yeah, 10 millimeters high, and the center shaft is actually the center shaft should be 6. It is 6. And probably also 10. It is. Let me grab, probably this one will work. Yeah, it will. A little more. One important thing actually is it has a little blob here, like a locking pin of 2.7 millimeters. I'm pretty sure. Well, it is aligned with center. So let me project this here. Let's make it horizontal with that one. And this thing is this is important so we can make the hole on the panel to lock it in place. It's very, let me see if on AliExpress it's actually the design, the dimensions of it. Well, I doubt it, but yeah. Okay, let me Google the reference. Since this thing is have a specific reference. Let's see, images. Oh. Actually, yeah, 2.8, 10 millimeters. Okay, good. So it's 10 from the center. And let's move it up. I don't know, 1.5 millimeters should be fine. Yeah, 2 millimeters. Whoops. 2 millimeters. Yeah, like that. Good. Now let's make the cap on this thingy. .8. Okay. Let's create an offset plane from here. 7.8 millimeters. And here, let's create that. And so that's 9. Let's put 9.1. .27 millimeters. C 27. E 14.7. Okay, that didn't went as planned, but Let's do something else then. Three point what? 3.2. Should be about 23.5. About 11 mils. Okay, and finally, let's just over the top. P -1. Boom. Okay, that's good. So now we have two bodies, but so create component. Let's move this body to this component as well. Yay! Welcome back as well, another CG. Yeah, long time no see. I've been extremely busy. And yeah, basically today I had to force myself to stream. So, because we need to keep this going and yeah, so let's call it pot. Let me do just a chamfer here to make it a little better. Good, so we have the potentiometer as well, so now we need the screen. Let's get the screen. So I have this one already open, no point. Open the other ones. So the screen, it's 25 by 51.5. And these as well. So a rectangle, 50 what? I don't remember. 51.4? Yeah, 51.5. 1.5 and 25, right? Yep. Good. And we have a few holes on the corner. So this is a PCB. X for construction. I'm gonna call these 3, even that they are way bigger. 3.8. 3.8. 3.8. 3.8. So we have 50.1 actually. 50.1 minus 3.8. Whoa. 50. and $23.7 minus 3.8. Now create point, midpoint, 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 midpoint. Now let's make these vertical and these vertical, and we are centered. E for probably 2 millimeters. Should be 1.5. And now the actual screens. $38.4. Damn it. 38.4 and $19.1. Good. Now from the top 3.6 and from this side probably it's centered, so we have 6.9. Come on. How much from here to here? 620. Let me check. Well, yeah, it's about right. We have a lot of room. Yeah, it's about right. A lot of room on the holes. And the height 8.3. So most likely we're gonna make some kind of 3D printed mount for these. We'll see. And let's call it 7D TSP. Oops. Okay, that works. And yeah, that's pretty much it. Plus we need an Arduino dummy. So I think I'm gonna just go to our friend Google, Arduino Mega 3D model. Oh shit. Okay, that works. Need to go on my personal. There we go. Jesus. Oh, okay. Probably it's a very oh yes, it's a very detailed model. I didn't need that, but it's what we have. How can I that will work. That will work. Good. Okay, so let's upload that file. Download and what is Arduino? The fuck? Why this thing up? Not what I want. How's the file called? Okay, Arduino Mega Step. Okay. Makes sense. Upload, move. Okay. List, nope, details. Yeah, that. Okay, so we should have this guy in here. Yeah, that's more than good enough. Way more than good enough, to be honest. Okay, so I think we have everything. Yeah, I'm thinking I need to look at this guy. Okay, so the doors, yeah, the doors are a pain. What if we put the door opening to this side? We can do that, right? It's the same thing. Actually, it's better. Because the machine, it's a little more on this side. If we put the doors opening to this side, because it's exactly the same, it's only the hinges are on the other side, right? Yeah, it's literally all the same. It's just the handle goes to that side and the hinges come to this side. No, I'm gonna have both. I'm gonna have both T-stops. I'm gonna have an E-stop on the console, and I'm gonna have an E-stop on the box. So basically, it's even better because I'm gonna have an E-stop on each side of the machine, and it doesn't really matter if we're gonna E-stops. We only use E-stops when the machine is running anyway. But yeah, it's gonna be on the right side. Since I'm right-handed, I think it's better. Yeah, that's what we're gonna do. So we're gonna put it on this side as planned, because I don't have space on this side, and it's on the left side of the machine. I don't like that. So yeah, we're gonna move the hinges to that side. No, we can't move the hinges to this side because of these stupid covers. Unless I modify them. Well, I can always modify this part to have an opening here for, well, actually this part, to have an opening here for the hinge. Actually, I want to put at least 3 inches on the doors. I think 2 inches is not too much, or even 4. So it's going to be fine in here, as this thing is opened, and here as well. So yeah, I just need to modify these parts. It's not difficult at all to put. I haven't printed them yet, so yeah, I'm going to modify this, and we're going to move the hinges to this side, and we're going to open to this side, to this, yes, to this side. Yeah, it's going to be better. That's what we're going to do. That's what we'll do. So I just need to modify these 2 parts in order to accept inch in here and 1 in here. Yeah, I prefer to use 4 inches. 3 would be ideal, but I'm not. Well, I can always print more of these and use 3 inches and 2. Actually, it's not a bad idea to use a couple more supports for the acrylics. Shit, I don't know. And if I do that, we can use the decisions. Well, fuck that. Yeah, I'll modify. We're gonna use 4 inches, and I'll modify the parts. This part and this part to accept an inch, 1 in here, and 1 in here. So this thing only holds in place. Oh, okay. It has screws on the inside. Okay, I see. Good. Oh, I see. So what do I need to do more? Okay, so we need 3 screens. So let's... Can I create a folder? Nope. Okay, so we need 3 screens. Probably we're gonna do a 3D printed part to hold all of them, because I think it's the best way. We're gonna need 3 pots. Where's the pot? One holy sheet button. So these guys we're gonna need a shitload of them. So we're gonna need 10 for the axis, 11. So 1 for rapids. I don't think we need more. So 1, 2, 5. Motherfuckers. And we need 1 more. Okay. Now the small ones, what do I want? So I want one for to disable the coolant, and I want another one for what for? I want another one to force coolant. Then I want another one. I'm not sure if I'm gonna use just air for cheap evacuation. Probably. If I want to use a puff of air. Could be a good idea. Let me see how many of these small ones did I buy, because I don't mind to have unused. I have a bunch of them. I don't mind to have unused buttons if I want to add functions later. So I have 6 at least. No, I have more. I have 10, so that's fine. Especially because I'm not sure if I want to use the lights on the light switch on the machine on the where we plug it in. So yeah, let's put something like 5 of them. 5 of them looks good. We decide later. Oops. If we need more stuff or not. I need to take a look into my... I may want to use it as a macro. So... yeah, I think it's fine. Spindle hollow light. What's a spindle hollow light? Let's check. Oh, I see. It's like a lead ring. I bought those when I first built my router, and yeah, I still have them in the bags. And I built my router 14 years ago, 12 years ago, something like that. Yeah, I seen them. Yeah. So the ones I got are let me see. Yeah, the ones I have are something like probably no. This wasn't the thing. These yeah, more like this or these. So there was no such thing as a continuous LED light back in the day. So yeah, it was something like this. It would be used for the cars, but it was with multiple LEDs instead of these continuous. But it had a cover. It wasn't like that, just a PCB. Like these maybe? I don't even know where I have them. I know they are downstairs. These are cool, but yeah, it's just more wires to put on the Z. I never got to use them. I have them downstairs somewhere. Okay, let's go back. Okay, good. So as for organization, I was like, where's my screen? Well, if you're gonna go that way, I would buy just some clear soft plastic, thick one, like 1 millimeter, 1.5 millimeter. I know there is that stuff, and just make a shoe and then attach with screws or whatever the plastic. And you can cut it in stripes, not the full way, just to leave as a skirt. But you can cut it. And that way you're gonna be fully clear. Because if you're gonna print clear TPU, you won't see shit anyway. Okay, good. So let me unground the nah, it can be ground. We can build a okay. I'm gonna create a new component and I'm gonna call it axis buttons, and I'm gonna move all the switches inside it. This way I can, yeah, okay, that's what I want. Then I'm gonna create another component. It's gonna be called macro buttons. Even that I have no idea what they're gonna do. Where yeah, I use a brush on mine. I don't, because I don't mind not seeing what's happening in there on my router, but I already know what it does, all the programs, so I'm not very concerned about seeing. But yeah. Okay, so I'm gonna create another one. Wait, I'm fucking up now. Yeah. New component. I'm gonna call it. I'm doing something wrong. Okay, I'm gonna call it what? Feeds. But I'm gonna move the pods and the displays. Okay, everything else should be fine. Good. So I'm going to create a new body now. I'm going to use the front of the screen as okay. So let's create a rectangle a little bigger than the screen. And let's start deciding stuff. So I don't want it too large, and to be honest, the screen is kind of big already. But I think it would be cool if we had the screen top camera, where is it? It's here. So if we had the screen and the oh, I know what are we gonna do. No, we're gonna do another way. So we're gonna do, I think. So let's put something like, I don't know, 20 millimeters or 25 millimeter edge from the screen. And what the hell is this? Okay, we are window. Let me remove the mega from here. Good. Okay, so I think it's important we get the axis in here. So I'm gonna make what was it? 20 what? 2? 25. Okay, good. 25. So 22 millimeters. So we need we're gonna need a square in here. Oh, we don't need a square. We're just gonna need a bunch of. I could use a pattern here, but I won't. So we're gonna need Okay, so on my VMC, I have 9 buttons, but I don't really like it. I have 9 buttons for the axis like that, where I have the X, Y. Well, let me make 3 more. But for the other way, I'm already used to it. And now it is. So we have, how is it? So we have X, we have Y, and then we have a Z and A, or A, I don't remember. How the hell is it? Shit, I don't remember. Let me check. CNC Milo 1000 MDC. CNC system. Yeah, okay. Yeah, this guy. This guy. Okay, this one is already different from mine. Or maybe it's not. What is he? No, this is not. CNC system. TDC, MDC. So this is mine. Yeah, I think they changed the panel. Yeah, I think they changed this one doesn't even have the Z. Okay, so this is exactly like mine. Yeah, that's it. Yes, that's it. So I don't really like that arrangement. So I think I'm gonna do different. I think I'm gonna do a cross. So like this. So that's gonna be Y plus and minus, X minus and plus, happy. Then I'm gonna have 2 in here, which is gonna be probably like this, which is gonna be Z plus Z minus, and then 4 more, not sure, well, doesn't really matter. The fuck? What's going on? Fusion is acting up. Okay. And then we're gonna have the B plus, A plus, B plus, and A minus, B minus. Probably I'm gonna, no, I can't. Yeah, that looks good. Then we can put the 16 mils in here. One more. Like that, a little closer, of course. And then the 39 by 26. No, 39, 26. Fuck. And then the potentiometers under 9, 9, 9. And the other guy, the holy shit button, 22 as well. Probably in here. Yeah, I think I like that. Okay, let me just make a few 25s in here, just so I can figure out the distance. Good. Here is 18, if I remember correctly. Yeah, the nuts are bigger, so I need to take that in consideration. I don't even know how I'm gonna make these. I'm not sure. what material. I'm gonna use to make the panel. ACM would be cool. Yeah, probably ACM would be a good idea. We'll see. 3mm ACM. Probably it's too thick, but the pots are 27. Yeah, the ACM would be cool because I can cut it and I can engrave stuff on it. Even that, I'm not sure if I'll need to engrave anything. Okay, good. So, first, let's align all of these. So I would align this with this, I would align this with this, I would align this with this, and then I would align this one with this one, this one with this one, this one with this one, this one, these 5, also all aligned. These bitches all collinear, so good. And 3 points. Where these guys are all aligned as well. And these guys all aligned as well. Good, good, good. Okay, let's start setting measurements. So this one to this one, oh fuck me. This one to this one, 29 maybe. Let me make sure 29 is actually fine. So the 29. Nah, let's put 30. Let's go 30. Just to have a little more room for the nuts. Good. Now we can put something like 30 as well. And from the top of the screen, or the bottom of the screen, as well 30. So here we can go 50. Yeah, I think it's fine to be kind of in a line. Well, to be honest, yeah, I'm good with that. so one thing I know is this one is gonna be 32. 32 looks good, and these two gonna be something like 30, and probably 32 from that one, and probably I'm gonna align this one. Maybe I'm gonna do 35 in here. Maybe I'm gonna do 48 in here. That looks kind of good. So these guys can be 30 millimeters as well from each other. Looks good. Maybe I'll put another one. Doesn't really matter. I'm gonna make an independent 25. Looks decent. From that guy, and 45 looks decent as well here. So yeah, maybe we put another one. Just why not? If we use it, we use it. If we don't, we don't. Doesn't really matter. Now, it's important to be at least 15 millimeters between these two. So let's set it 20. And here, let's see, 20. 20 looks good. Uh, 30 probably looks decent, and 40 maybe. Yeah, probably it's still too much, right? $35. Yeah, 35 looks good. So now this guy can be a little isolated in here. Probably aligned with this one. And maybe in between these two for the, so the OCD doesn't trigger too much. Right? It's good. Now we can put this one. Oh, actually, let's make it a decent size. $400, maybe 405. Good, I think. So this way we can 3 millimeters. Nope, I fucked up. Yeah, I like that. Okay, so let's start moving stuff. Okay, first, let me change the appearance of that guy. Set it to black. Good. Now this guy is gonna go here. Well, this is the first mock-up. We can tweak it. So oh, actually this is a square. Your router is exactly 400, or I usually cut ACM with 1/8 of inch, one flute carbide mill that I ordered eons ago. Oops, I fucked up. Selected the wrong. What am I doing wrong? Edit joint. Okay, actually, because I'm asking because my my 3040 actually cut it a little more than. Oh, okay, I see. I need to flip it. Oh, and I forgot something. Yeah, but again, this is the first mock-up, and it's not even. We can adjust, we can fine-tune it. And you don't need to. I'm not sure. Are you planning on making a panel like this one? I can share it, there's no problem. I'm doing this by my taste, not exactly Hey, Happy MFG, how are you, my friend? Good. Okay, I need to change this, and this. Good. Now we are good. So if I did everything right, yes, we have the pin there. Yeah, I think I got, let's be honest, I got used to my VMC, and I really like to have um, some a control panel handy, especially with some stuff like jogging. What have I done? Okay, it's the other way around. Some macros. Yes, the touch panel already does a lot of the stuff, but physical buttons are always appreciated, and I really got used to my VMC that doesn't have the touchscreen. And to adjust stuff on the fly, I really love the feed and the spindle. It's kind of I would prefer a rapid knob instead of a feed on my machine, but yeah, it's what I have. No, keyboard it's jogging. It's just for rough positioning, very rough positioning. If you really want to jog with precise, you need a pendant. Okay, good, I like that. I only use the jog buttons really to make the most of the movement. Then, because I use a manual probe, it's different as well. So then I use the pendant to do the rest. But yeah, here with the touch screen, we can easily get to the probe menu. We just need the jog to actually do the rough positioning. And again, I'm going. Oh, also now that we are talking about my pendant, it's wireless, and I also need a USB for it. So yeah, 4 USBs on the mini PC. It's actually great. We're still gonna have a spare one, and if we need, we can actually buy a hub. And if we buy a hub, we need to buy a quality one, not one of those super duper cheap ones. that will work for a week. Even that on my router, I jog with the keyboard, and that's fine. But I need to be always messing with the feed speed or the jogging speed, and then I need to do steps like pressing on Mach 3 to press Control to. Okay, that's it. To do stepping, and it moves like 1/10 of a millimeter per step. Okay, now these guys. What's the best way to align them? Okay, best way, I think it's like that. Find components. Oh, whoa, 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 whoa. I fucked up somewhere. Oh, okay. I need 20 millimeters. I need 26. Okay, fucked up here. Shit. Okay, so let me first. Oh, okay, that. Okay, that way. Yeah, that way we can actually do the 400, probably. Let me just buy high. Okay, X distance, 0.4. It's too much, 0.3. Probably I need to make the holes a little bigger. Minus 0.4. 5. Yeah, that looks centered. Good. So, Shift J for as built, and we are good. Line components. Line components. Line components. Good. Now move X distance 0.3, right? That looks decent. Shift J, boom. Same story, align, align. And now move, fuck, that direction, 0.3. Okay. Now this looks very nice. The only thing I would love, I need to find a way, or I would like to find a way to fix these guys without showing any screws. Would be super nice. Well, I'm gonna need to use screws anyway around, so putting 2 screws here on the middle, it's not gonna be the end of the world. Looks super clean, right? I really like it. Okay, now the only thing left is actually the keyboard. So what I would like would be something like, I'm gonna make it in here. Yeah, okay. Let's start thinking and do something. Okay, so the keyboard is 9, how much is it? 100, right? Yeah, so let's say 135. Let's make it 3 for now. Ah, fuck. Perpendicular. Let's make this. Yeah, that angle, it's, let's put it 135. So at 45 degrees. Yeah, maybe a little less. 125, maybe? Yeah, 125 looks good. Yes, okay. Okay, I think the idea here, so my idea is to do just a plate with a hole, and then I'll do a 3D printed part on the back to hold the keyboard. So here we're gonna use a hole on the size of the keyboard, a little bigger. So to something like 262, and like 100. Is it really 100 or? No, it's actually 98, so I'm gonna change the design. So I'm gonna make it 100. Create 2 points. Maybe. Yeah, maybe I won't center it. I'm gonna center it like that. Probably I'm gonna leave it a little more to this side. I'm gonna leave that side open for something. So a boom, like that. A cup holder. Yeah, it's a little lean for a cup holder, but it's not a bad idea. It's not the worst idea at all. It's not the worst idea at all. Yeah, a big cup. It's not the worst idea at all. I'm probably gonna make a square as well, and then we do just like a shelf for something. Notebook, pen. We can make it 3D printed with some holes for a pen or two, or a, yeah, that's not a bad idea. That's not a bad idea at all. Let's leave like 20 millimeters on this side. Probably same here. And here we'll just do the same as the keyboard. No, clean here. Yeah, no, I'm not liking that. Let's make the same as the keyboard. I'm gonna leave a little more there. It's looking kind of thin. Let's make 20. Yeah, like that. Good. Okay, so now I'm gonna make. Go. So shit. Where is this? Shit. God damn. Fuck. I made it on the inside of this. Shit. Okay. Let's do create. Let's move these outside. Ah, good. Panels. Let's make panel 1. Now let's move this guy inside here. It's going to be panel 2. Good. Okay, so now for the keyboard, I'm gonna just create a box. Something like 8 millimeters bigger. Oh, actually, it's easier to do it this way. Let's make a project and let's make an offset 8 millimeters. Okay, minus 8 millimeters. So 15. Okay, like that. New body. Good. Wait, where am I? Okay. Yeah, that's I need to create an offset plane. Minus 8. I'm gonna create a drawing here. I'm gonna hide this panel. I'm gonna project this guy in here. I'm gonna make a line here. So the keyboard is 15. We have a 3 millimeter panel, so 12. And we have a D, 8 millimeter from here. Here we have 5. And we have a line that goes there. I think I'm gonna fuck up because this thing has feet. Yeah, I'm gonna make a flat of 12 first. So I'm gonna make here a flat. And from here to here, we should have 100. 100. Good. Fuck that profile. 262. Motherfucker. Minus 252. Good. So this is going to be a 3D printed box. We're going to make it a little more beautiful with a couple screws. Of course. .6. 4.6. 4.6. 0.6. Everything horizontal. Everything horizontal. These ones verticals, these and these vertical, these and these vertical, and 2 points. Let's make a point. Where do we have? Where is the center? Should be here. There. 4 mills there. 4 mills there. 4 mills there. We're gonna round some corners. Yeah, that should be fine. Now E. This is just for sketch. Minus 5. Now we can do something like that on this side as well. This side needs to be different. Okay, let's do an offset of 8 as well. Minus 8, actually. Good. But now I need, how can I? Yeah, this one needs to be different. I need to work probably, yeah, okay. Let's do it this way. Let's do it all. Yeah, I see. So from here to here we have 12 millimeters. Probably there's an easier way to do this. But I'm minus 12. Let me see if this works. P and align straight and P as well. Vertical. No, okay. Yeah, okay, that will work. No, this is not needed. I'm gonna, well, I don't know if it's needed or not. We'll see. The something like 3 millimeters. No, probably we need a little more. 5. Like that. Okay, now let me see if this works. So if we do a sweep, this profile, this path, aha, works. Oh no, it doesn't. It kinda does, but it doesn't. Okay, yeah, I'll take it. I'll take it, I'll take it. I will take it. So now let me do something. No, no, fucked up here. I need to create a new body. Yeah. Fuck. Now I fucked up here. I only need it until here. Good. Okay, let me do something first. Okay, first we need to round some corners. I'm gonna round these at, I don't know, 3 millimeters. Should be fine. Should have done these before, but yeah, doesn't matter. Because now I want to shuffle this like 2 millimeters. So this way we can create a line in here. Should be a little more. Okay, let me delete this line. Now it can be a little pocket. It's gonna be great to accumulate dust, but it doesn't really matter. We can leave it as a little pocket. Like 3 millimeters here, 2.5, 2, no, 2.5, 3 millimeters, fuck it. Yeah. For stuff. Okay, I like that. I like that very much. So let's hide the panel. Let's put 4 holes in here. Same story, 4.6. Why 4.6? Because it's the diameter for the inserts. So D4, D4, and D4. Now this with this, this with this, this with this, this with this, and D4. E -5. Okay, that's a little problem that we can fix. So we're gonna print this like that. So we can fix this. By putting a little formula should be fine. Yeah, we don't need the full length. Doesn't really matter. Well, we're selecting the wrong face. So we're gonna project that. And -10. 8 would be enough. Let's make 10. So these won't be a problem printing. And now shouldn't be a problem with the... Oh, actually still is. Need a little more. Oops, not this one. This one. Five enough? Yeah, 5 is enough. Good, so now we can call these the cup holder. And these the keyboard holder. And this one can come here as well. Hey. Good. And now on the panel tool, we can project these little guys we can select them all and press X for construction, and we can make actually 3mm holes in it. Don't really need it. I could have left it at. But I'm still not sure what material I'm gonna be using for. Because I really would like something that I could cut with a laser cutter instead of milling. So I'm really thinking about MDF. Okay, it's fine. Good. And cut. Boom. So we have the screw holes for the stuff that we just made. Good. So now we can move the keyboard. I have no idea. Align components. Perfecto. Well, kinda. Okay, let me align this one and this one. Whoa, 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 whoa. Let me ground this guy. Okay, now I should be able to align this without much trouble. And now I should be able to move this guy. Let's change the people. Oh, actually the people is fine. Can move it. $82. Wait. Minus 6, 5, 6. That should be something like this. Doesn't really matter. It's good enough for. Let me change this guy to black as well. Oh yeah. I like it. I like it. Now, how are we gonna close this guy? So we don't need much thickness. I'm thinking, what's the best way? Well, I know the best way. So the best way is to at least the sides be in wood, and we just do it capture position, and we just do it like that, like MDF or something. So yeah, okay, let's go like this. Here. Here. Need to project this guy. Here. Here we're gonna need to, oh, that would be perfect. Oh, so if we do this in ACM, oh, that's gonna be genius. Oh yeah, okay. So if we're gonna do this in ACM, we can actually make this in one part. Because we can, ACM is basically a sandwich. So it's aluminum, plastic, ABS I believe, and aluminum. So we can just make a cut without cutting the bottom aluminum sheet. So we can make just a cut here, and then we can bend it to make this shape. Oh, that's awesome. And we can do another cut in here. And actually bend it again. And finish in here on the bottom. Oh, that would be perfect. Oh yeah, I think we can do that. Yeah, then I need to, yeah, I'm gonna make these small. 25 millimeters, something like that should be more than fine. And I'm gonna go straight. No point on going in angles. So I'm gonna go straight. Good. Here we don't need much. Yep, exactly. We can use like a chamfer or a 90-degree beat, whatever. A chamfer on the back to cut it there. So it will bend. Because it will be weak, it will allow to bend. It's gonna bend straight because all the material, all the material from the back has been removed. And then we can do the same here for this one. If we remove this So it's basically a chamfer here. So for that, I think we're gonna need to make these 35 millimeter perfect angle in order to make this bend here. Yeah, it's gonna be fine. It's so small, so it will bend anyway. Okay, here we're gonna go, we don't need much because we're gonna have plenty of room in here on the bottom. So here let's put 55. And here we're gonna make it straight. So here we can do like MDF 12 millimeters. -12 new body. Okay. I need to increase or decrease this one a little bit. This one should be fine. Okay. So let's go back to this guy. Yeah, here. Let's increase these to, we can decrease this one to something like 18 and increase this one to 22, and everything should be fine. And now we have a gap. Yeah. And here we can put the rest in here. I need to make some corners to hold, or some parts to hold the screen in place. So the screen, we need at least 8 millimeters, so we can actually remove, we can't remove much. (19, 12, 7, 5, 2, okay. Okay, let's make some adjustments again. For me it's fine, I'm just thinking in order to keep this thing under 400. So let's make it 20 millimeters on each side. I was like, okay, where is the, oh, it's here. Okay, so this one, no, this one. Now we're going to have problems, because I need to, let's make this 20. No, this needs to be 22. Where? Fuck off. Okay, everything looks good. Now just the keyboard position. So we have space there. I may need to adjust these ones. What's these ones? Yeah, these ones. Edit. I may need to adjust these a little bit. Just a little bit. Let's make it 32. Should be fine. How much from here to here? 5. Yeah, should be fine. Oh yeah, it's more than fine. So same story. Yeah. Okay, so this one is the side panel. We're gonna need 2 of them, but that's irrelevant. We can make it. Let me activate this so we can work only here. We just project that and finish and well, boom. Oops, I need to create body, not join new body. And this is going to be side panel as well. You know what? I can do the same for the back. Or we just go over it. Doesn't really matter. So 400, 535, yeah. So 560. Yeah, I like that. I like that. The top doesn't really matter. We can put a piece of MDF as well. The back. Okay, I think at least the bottom and the back and the top should be also MDF 12 millimeters to make structure. We need to figure it out how we gonna let me see if everything fits fine. Yeah, everything fits fine. So new body. And we're gonna call these the floor. I may add a little more. No, it should be fine. We have plenty of space here, even if we need a small 5-volt power supply in here. We have space for the wires. Yeah, should be fine. So another piece in here. New body. And we can use direct screws from here to the thingy, which is awesome. I'm just thinking maybe I should increase the angle a little bit on this guy. I'm really not feeling this guy like this. And if we put it at 45, where is it? Is it here? Yes, it's here. Let's see. So if we put this at 135, it will make everything easy. I'm not sure. Yeah, of course. Of course, it fucks up something. What is it? Could be worse, to be honest. What's this? What's the oh, we lost projections? Oh, we lost, okay. Okay, I see. Okay, so the problem is actually before. Oh, okay. Okay, so probably we need a little more. That's the problem. Here. Let's do 140 instead. Let me move a bunch. A bit more. Okay. So we have that. Oh, okay, I see. No, I don't see. Okay, I have this sketch. Probably it's this, no, this one. Yeah, okay. Oh, okay, I probably see. Need to edit this sketch. This should be under, not on top. Yeah, okay, that's the problem. Okay, wait. What's the problem now? Oh, okay. That's our, okay, yeah, I see. Because I haven't placed the actual number in here. Let's put like 10 millimeters in C. Yeah, everything is fine now. Good, so now we only need to adjust. We don't need to adjust. We know what's going on here. Align. And what? Maybe align these. Let me check something. Construct. No. Inspect. Section. I'm getting tired. Probably we're gonna... Yeah, okay. I see. I see. So the problem is we need to... We need to adjust the keyboard. Where is our keyboard? It's here, move. Okay, let's rotate it a little bit. Yeah, like that. And now move it a little bit. Okay, we need to make the hole a little bigger. Oh, did I change the size of it? I don't think so. I don't think so. Jesus, I don't even remember when we did the keyboard. Oh, keyboard, it's actually here. Yeah, I didn't. Okay, this is 98. Oh, motherfucker. I need to save, because I haven't saved in a long while. Good. Yeah. Okay, we need our keyboard. Move. Yeah, it should be something like this. Not sure about yeah. Probably something like this. Yeah, something like that. So looks good, right? I think so. I don't want to overcomplicate stuff to make. So we can capture position. So here we're gonna bring this as well. That cut, it's not gonna be like that. I need to fix this. This is something I need to fix. I can make like that, should be fine, but I need to fix this guy, which is like here. I need to delete this one and this one. This one is okay, it doesn't really matter. This one is important. But this one here, sorry, this one here should be I'm gonna make this is all construction. Because I just want to, what's going on here? Okay, so we need to set these as parallel, these coincident, and now I can move that. So if I'm right, so this should be, it doesn't matter what it should be. It matters, it is like that. Yeah, it's 135, so if we pass here on this line, along this line, bit, chamfer bit, so 90 degree, we're gonna make this bend just perfect, and that's what we want. New body. So we can make all of these in one go. Thank you, Charlie. Of course, man. I'll post on Discord. I'll post on Discord. Okay, we have movement here. So where are these joints? What? Oh, okay. We don't have joints. probably I need to move 5 millimeters. Yeah, that's exactly it. Hey, but I remember making joints. Oh, okay. Never mind. Okay, so you can make these all on one part. And we just need to cut these. It's not serious. It's not that easy. And the back plate, we'll see. Yeah, I think it's gonna be cool. So the idea is gonna be x minus, x plus, y plus, y minus. So this one is gonna be to activate the rapids. So if you press that and you jog, it's gonna jog fast. And if you unpress it, or it's gonna be a large one on this one middle. And if you just have it regular, it's gonna be at the feed, the selected feed. So this is going to be Z plus, Z minus. This is going to be, I'm not sure how, but probably it's going to be A minus, A plus, B minus, B plus. This is the holy shit button. So this is going to be probably the feed. So the feed speed. So here we can go from 0 to whatever, probably 300. And it's a pot. We're gonna have a 7-digit display there. So we're gonna see there the value that's gonna be set. Same for here. These probably it's gonna be the rapid. And this one it's gonna be for the spindle. These ones not sure yet, but they're gonna be there for whatever. For sure, for disable coolant. For sure, for activate coolant, if we forget or whatever. And probably for air. So if we want to do an air spray or something like that, just press that and it's gonna blow some air. And these three, it's gonna be for whatever we decide to in the future. Probably I'm forgetting something. I'll probably even move it a little upper in case of I want to add more. It's not a bad idea. So I still need to make at least some corners or some brackets to hold the screen in place. So if I did my math right, I think I have 8 millimeters here. It's kinda, well, 8 millimeters, it's more than enough. Especially we can use just a what about here? Yeah, 13 millimeters, that's fine. So we can make just a top and bottom bracket with a little spacer on the corner. So it should be okay. And we only need like not much. We only need in theory like 6 millimeters to put the screws on. Actually, I need to design that in order to put the screws on the panel as well. and we're gonna need to put some screws here to attach to the MDF plates. I think we're gonna go with MDF. It's easy to get, easy to paint, easy to machine or to cut. And then we just need a back panel. I think this is enough space for the all the wiring and stuff. We're gonna need to put the Arduino in here, and yeah, that's enough for sure. And we're gonna need to put, I'm not sure if you're gonna need any kind of power supply in here, maybe, because we need to power the screen, but the screen we can get power from the so about the connections on the screen, we are good because it has a recess. I only did a dummy model, but if we do, let me change cameras. Yeah, front camera. As you see, the connections are actually there. I think, yeah, there. So we have USB and micro HDMI. So this is a thing that we're gonna remove, a stand that we're gonna remove because we don't need it. So we have space in here for the cabling. So yeah, I think we are good. I think we are very good with this thingy. So we only need to find a way to attach it in here somewhere. So let's put it on the side of the machine. Oh, sorry. I need to change the... I hate when Fusion just quits on me. Move. So the idea is to have it somehow actually, the idea is to be able to... Not sure about the height yet. Yeah, the idea, we're gonna make a what's that? Oh, it's the Arduino. Doesn't matter. But yeah, the idea is to be able to swing it like this, and probably, yeah, I think I'm gonna, I think I wanted to, okay, let me reorient it. So the idea is when it's I want to be able to put it there. I think. something like that. Doesn't need to be exactly that, but so I may need to change this part. Good thing that I'm already printing it, but that's fine. And probably this part as well. Or I need to remove this part. In order to make it swing. So let's just make some, what time is it? Shit, it's 1 AM. So it's time for me to go, so maybe tomorrow we continue. I'm really tired. And we did good progress today, I think. So these may need to, but tomorrow we're gonna do some simulation. So the idea is we make some kind of post in here, maybe with a bearing. I don't know. Yeah, at least on top it should have a bearing, and on bottom should have a truss bearing. Yeah, I think that's a good plan. So basically, here, yeah, we can go on panels. Here we're gonna need something like this, capture position. We can make it full size or 50 by 50. Why? Because I fucked up. We make it there. 50, 50. Let's make these, doesn't really matter, but 40, 40, and 40. Probably we're gonna change these, but doesn't really matter. This is construction, C 4.3, 4.3, 4.3, 4.3, and E10, something like that. We're gonna round it. 5 maybe, yeah, that looks, no, that looks too much. Yep, that looks good. Then something like C, fuck, L for line. Let's make a line in here. X, C, 35 maybe. Let's make the outside first. 45. Yeah, 45 looks good. C, 35. That looks amazing. E, probably 20 millimeters. I don't know. We need to check for bearings. What can we use for bearings? Yeah, that looks good. And this thingy, where is it? Hey. Oh, okay. Okay, so this is the top. And this is the pivot. Top. Move. Now we can move this somewhere in here. Maybe. Well, it doesn't really matter. I'm gonna put a screw in there. Or two. Yeah, it doesn't really matter. For now, it's gonna be here. Same story on the bottom. I'm gonna just stop, project. We don't even need a thrust bearing on bottom. We can use the exact same stuff on bottom. We just need to make sure that the bearing sits properly. Yeah, that's going to be fine. So yeah, that's fine. I'm gonna copy this guy. I'm gonna move it back. I'm gonna rotate it 180, and I will join there. Oops, no, not join. Need to align components. That's what I need. Align. Yeah, that. And remove the sketch. I don't really. Oh, whoa, 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 whoa. Where is the sketch? Oh, probably it's here. It doesn't matter. So we're gonna need something like that. Top and bottom. That's a plate. Good. Yeah, we have space. So probably we're gonna get a few bearings to put in here. I need to check. So that's for tomorrow. Tomorrow we're gonna take a look of bearings. Probably we're gonna need these walls to be a little thicker, or at least put a big ass, put a chamfer in there. Doesn't really. This is just the first sketch of this. We're gonna need to adjust it, but Yeah, probably this needs to be something like more 30. Let's check. Let's take a look, just a quick look to Brave, yeah, here. $30mm or 32mm, we'll see. 30mm, what? 30mm bearing. Yeah, I would like, yeah, something like this. So this is 30 inside. So this is 30, 42, 7. So let's see the 6805. Bearing 6805. So the 6805 is 2537. Okay, what about the 3804? 3804 bearing. It was 38, right? 6804. 6804 bearing. Okay, 68. Oh, fuck. Okay, 6804, it's about perfect. 3227. So actually I'm probably gonna buy them already, but yeah, we can wait. So we can use 3 of them on top and 3 of them on bottom. They are cheap, so 10 pieces, $6.50. So that's 21. So we just need a little more meat. So we have 32. Probably we need to adjust. And yeah, I think we can go with 46. Should be fine. Yeah, I like that idea. We can increase a little more these if needed for better support. If we find we need it, doesn't hurt to add 1 more centimeter in here instead of 5 to put 6. Doesn't hurt at all. Where is it? Here. Instead of 55, 65, just 1 more centimeter, and we have more room to put more meat in here. Doesn't really, and just adds 1 more centimeter. Doesn't hurt at all. So we may do that. So I'm gonna actually leave it like this, and we're gonna actually order, or at least add to cart the, oh, you guys weren't seeing anything, sorry. So I was saying, increasing this thickness, just 1 more centimeter, and we have more space to make this part a little beefier, even that this controller won't be that heavy, but it will be a little heavy. So yeah, so 10 bearings, $6.50 sounds super cheap. So we can use 6 of them in here, and then we just need to make the poles, and it looks like it's gonna work just fine, if you ask me. So we just need to make like a hook in here, like a part that's gonna attach at this corner, and probably it's gonna move this way. Because if it moves like that and the rotating point is there, yeah, I need to simulate the stuff. Probably it's gonna move on the diagonal here, but yeah, we're gonna check that tomorrow, or yeah, tomorrow probably. So yeah, I'm gonna save everything. So we're gonna need to run an HDMI cable to here, a USB-B cable for the Arduino. What else? USB-C for the touchpad, and power. I think we can do both. I'm not sure about that. I guess I need to do some tests. So yeah, we're gonna need to run at least HDMI, USB, 2 USBs. So maybe we run 1 USB and one of those little USB hubs. So we can deal with touch and the. Now I want a dedicated line for the the Arduino, and and then for touch as well. But it wouldn't be a bad idea to run one of those small switches, small hubs for the USBs, and only 1 USB line come here. We're gonna need USB power, USB-C for power on the screen. And we're gonna need probably 5 volt. Hey Antonio. And because I was so stupid, I bought switches for that the LED is 24 volts or 12 to 24 volts. I should have bought all of them for 3 to 6 volt. but I was stupid and I bought switches that the LED is 12 volts. So I'm gonna need 12 volt, at least 12 volt. The Mega, oh yeah, the Mega has well, probably we're gonna run 12 volt and 12 or 24 volt, doesn't matter, and then we put a buck for 5 volt if we need for the Arduino. Even that I don't think we need. So we'll see. I don't even remember. I need to check. So the big switches are 24 volts. Shit, these ones. This one doesn't say. The small ones are 6 volt. Yeah, the big ones are 24, 12 to 24 volt. Don't ask me why. I was stupid enough to didn't think that truly. Yeah, the small ones are all 5 to 6 volt and the other ones are 12 to 24 volt. Yeah, because I'm stupid. That's why. I didn't thought it through. I should have bought everything 5 volt. Because the Arduino works with 5 volt. But I didn't. Where did I remove this thingy? Here. So, yeah, that's it for today, guys. Thank you for... Oops. Thank you guys for watching. Probably we're gonna continue tomorrow. I'm tired already, so time for me to get some rest. Yeah, hope you guys are learning something and enjoying this design. It's something that we need to do, and I wasn't really prepared for anything else. And I really wanted to stream something, so we're gonna finish this tomorrow. Tomorrow, within a couple of hours, we should be fine and finished with this. So yeah, I think that's it. Thank you for watching and see you guys tomorrow. I don't think I'm forgetting anything. So bye. Guys, goodbye, good night. Thank you for being here and dealing with my stuff. So yeah, see you guys tomorrow. Bye bye.